Imagine if we could harness energy just from the Earth's rotation, power generated without fuel, motion, or emissions. Sounds like something out of a sci-fi movie, right? Well, some physicists believe this is possible, while others are skeptical. In today's video, we'll break down this groundbreaking claim, explore the science behind it, and discuss what it could mean for the future of energy. A group of researchers, led by Princeton physicist Christopher Chyba, recently proposed that electricity can be generated using Earth's rotation and magnetic field. They designed an experimental device that reportedly produced a small voltage, just 17 microvolts. But how does this work? In simple terms, the theory suggests that a specialized material shaped into a cylindrical tube could interact with the Earth's magnetic field in a way that generates an electric current. If true, this could be an entirely new way of producing clean, emission-free energy. However, not all scientists are convinced. While some say the experiment was carefully conducted, others believe the results might be caused by an unaccounted factor. To understand this concept better, let's look at how electricity is usually generated. In traditional power stations, a conductor moves through a magnetic field, pushing electrons and creating a current. But Earth's magnetic field is mostly uniform, meaning that normally, this movement wouldn't generate usable energy. Here's where things get interesting. Chyba's team claims to have found a loophole. They designed a hollow cylinder made from a unique soft magnetic material containing manganese, zinc, and iron. This shape and material configuration supposedly allow the Earth's rotational energy to push electrons without them rearranging and canceling out the effect. When the team tested the device, they observed a tiny voltage, but only when using the hollow tube. A solid chunk of the same material produced no effect. Could this mean that we've overlooked a fundamental way to extract energy from our planet? Not all physicists buy into this idea. One of the biggest skeptics, Rinke Weingarten from the Free University of Amsterdam, tried to replicate the experiment in 2018, but found nothing. He argues that Chyba's theory contradicts established physics. Some scientists agree that while the experiment was well designed, the voltage observed might be caused by external factors, like temperature variations, minor electromagnetic interference, unexpected material properties. However, Paul Thomas, a physicist at the University of Wisconsin, finds the results convincing and remarkable. If this phenomenon is real and scalable, it could revolutionize energy generation. Imagine small stationary devices producing power without motion or fuel, power sources for remote locations, space missions, or even inside the human body. A potential breakthrough in sustainable, emission-free energy. But let's be realistic. Right now, the effect is too small to be practical. At just 17 microvolts, it's a billion times weaker than what's needed to power even an LED light. What needs to happen for this idea to become a real power source? 1. Independent verification. More scientists need to replicate the results. 2. Scaling up. Engineers would need to amplify the effect by thousands or even millions of times. 3. Theoretical validation. Physicists must reconcile this with established electromagnetic theory. If future experiments confirm this phenomenon and engineers find a way to scale it up, this could be one of the most groundbreaking discoveries in energy production. So, what do you think? Is this the future of clean energy or just a scientific misunderstanding? Let us know in the comments below. If you enjoyed this video, hit that like button, subscribe, and turn on notifications so you never miss an update on cutting-edge discoveries. Stay curious, and we'll see you next time.